You think you're deploying AI, but in reality, you're deploying unmanaged identities. For the last 20 years, we solved identity in layers. First, we secured people, multi-factor authentication, conditional access, policies that verify who you are if you sign in from a new location. Then we secured apps, service principals, managed identities, credentials that let applications talk to databases without exposing secrets. We got good at this. We built the frameworks and automated the workflows, but we missed the layer. We missed the thing in the middle, the thing that acts like a person, but moves like an app. Now we have agents that can plan, decide, and chain actions across your entire environment. They read your email and browse your files. They update CRM records and escalate to humans when they get stuck. And we're still treating them like the workloads we built 20 years ago. That's where the system breaks. The old model worked because it was clean. Users had sessions, apps had credentials, everything flowed through a predictable channel. But agents don't fit that channel. They operate between the two. They act on behalf of users but execute like applications. They make decisions on their own but need oversight. They access multiple systems but shouldn't touch everything. This isn't about a new feature or adding another checkbox in your security console. This is a shift in how identity actually works. Why service accounts were never built for agents. Service principals were designed for a world that no longer exists. When you build a service principal, you're answering a simple question. What does this app need to access? A web service that reads customer records needs the database. A background job that processes invoices needs the accounting system. The answer is static. It's deterministic. The script does one thing every single time. AI agents work differently. They don't execute a fixed script. They see a problem and decide how to solve it. They choose which tools to use and chain actions together. When they hit a situation outside their original design, they figure out what to do next. This is non-deterministic behavior. And your identity model has no vocabulary for it. Traditional RBAC assumes a linear flow, identity to resource to permission. Does this service principal have read access to this database? Yes or no? It's a direct line. But agents don't operate in lines. They operate in networks. They access systems A and B, then decide they need to pull data from system C. They invoke one tool, and the result tells them they need to call another. The relationship between the identity and the resources it touches is dynamic. So what happens in practice? You assign the agent a service principal. You know it might need to read email, access SharePoint, query HR, and create tasks in Teams. You grant it permissions for all of those things at once. You give it everything it might possibly need. Because if you don't, it will fail mid-process. And failure is expensive. Tasks don't get done, users have to jump in, and the whole point of automation collapses. You've created a God account. Not because you wanted to, but because the alternative is worse. But that service principal now has access to broad swaths of your environment, and it's moving on its own. No human is watching every action. The agent decides what happens next. One compromised credential or one prompt injection attack is all it takes. One bug in the agent's reasoning and that blast radius expands across every system the agent can touch. This is the fundamental mismatch. Service principals were built for static, constrained workloads where you could predict every interaction in advance. Agents are dynamic, adaptive systems that make decisions at runtime. Forcing agents into the service principal model means you either accept huge security risks or you constrain the agent so much that it can't do its job. We need a different approach, one that treats agents as distinct from static workloads, one that lets you grant permissions based on what the agent is trying to do and who asked it to do that. That's the structural shift we have to make. The shadow AI explosion. Here is what is happening inside your organization right now. The marketing team wants to summarize customer feedback. HR needs to process job applications faster. Finance wants to reconcile invoices without the manual work. Every team has a problem to solve, and every team has the tools to do it. They have Copilot Studio, they have Azure AI Foundry, they have AWS Bedrock. So they build an agent. Nobody asks for permission, and nobody files a formal request. They don't go through a central approval process because that process does not even exist yet. The team simply builds the agent, connects it to the data, and deploys it. The work gets done, and the team moves on to the next task. But now you have an agent running in your environment that nobody in IT or security even knows is there. This isn't about people being malicious. It isn't a security breach or someone trying to bypass controls for a bad reason. This is just the reality of how work gets done today. Teams have problems, and they use the tools available to solve them. We saw this with Shadow SaaS, and we saw it with Shadow Infrastructure. Now, we are seeing it with Shadow Agents, but the difference here is the scale and the invisibility. With Shadow SaaS, you can usually see the data leaving your network through basic monitoring. With Shadow Infrastructure, you can audit your cloud costs and see new resources appearing on the bill. But Shadow Agents are different. They run inside the systems you already own. They use the credentials you already issued. They operate within the networks and data pools you already approved. From the outside, it just looks like normal application activity. The marketing agent uses a service account originally made for a different app. The HR agent uses Graph API permissions that a developer requested months ago for a legitimate project. The finance agent gets into the accounting system because an admin granted access for a completely different integration. In the audit log, all of this looks authorized. It looks normal. But those credentials are being used for something they were never designed for. The permissions are being applied to use cases that nobody ever evaluated. Risks are being taken that nobody ever assessed. And when something goes wrong, when an agent touches data, it shouldn't or sends info to the wrong place. The first question is always, what happened? The answer in the audit log is useless. It says a service principal accessed a resource at 3:47 p.m., but it doesn't say which agent that was or who requested it. It doesn't tell you what it was trying to do or who authorized the action. The log was never designed to answer those questions. Research shows that 88% of organizations have already dealt with AI agent security failures. When you look at the root causes, the story is always the same. It is a mix of missing governance, identity misalignment, and runtime policy gaps. The agents themselves weren't necessarily unsafe, but nobody had visibility into what they were actually doing. This is the real cost of shadow AI. The problem isn't that it exists or that it is running. The real cost is that when it fails, you are blind. You cannot reconstruct the event or prove what was compromised. You cannot answer compliance questions because you don't actually understand the problem. The old governance model assumed you knew every identity in your environment. It assumed you controlled where they were created and had visibility into their actions. Agents broke all three of those assumptions. The identity vacuum. The deeper problem isn't just that these agents are invisible, it's that our identity systems were never designed to understand what an agent actually is. A service principal only answers one narrow question. It checks if a credential can access a resource. It is a simple binary check. The system does not know if that credential belongs to an AI agent or a standard legacy application. It doesn't know who built it, who owns it, or what its actual purpose is. It doesn't track if the agent is acting for a user or moving on its own. It doesn't know the data boundaries or the risk tier. This gap becomes a massive problem the moment you try to manage agent behavior in real time. Traditional conditional access was built for humans. The logic makes sense. If a user signs in from a new location or an unpatched device, you challenge them. This works because human behavior is predictable. Users have patterns that the system can recognize as normal or strange. But an agent accessing 1,000 files in 10 seconds isn't necessarily a red flag. For an agent, that might be exactly what it was programmed to do. Querying a warehouse and returning results in milliseconds isn't suspicious. It is just efficient. Conditional access has no way to tell the difference between a legitimate autonomous action and a compromised one. The system has no agent-specific risk signals. It cannot tell you if an agent is touching a new type of data for the first time. It doesn't know if today's request pattern matches the historical baseline. Identity protection builds profiles for users, but there is no equivalent for agents. The platform sees a token request and only checks if the role is correct. Everything else is silent. The audit trail reflects this lack of information. When an incident happens, the log just shows a service principal ID and a timestamp. It doesn't tell you which team built the agent or what business process it was supporting. It doesn't show the data classification or if a human request triggered the move. The system recorded that a credential was used, but it didn't record the context. This turns incident response into a catastrophe. Security teams get an alert at 3 a.m. that sensitive data was accessed. They pull the logs and find the principal, but that credential might be shared across 10 different integrations. The team has to manually interview staff and hunt through code repositories just to figure out what happened. This process takes days or even weeks. The whole time, the organization is stuck in uncertainty. You don't know if data was stolen or just read. You don't know where it was sent. The visibility just isn't there to answer those questions quickly. The flaw here is structural. Our identity systems were built for a world where humans started actions and applications finished them. Users logged in and applications ran jobs. Both were easy to categorize, but agents exist in the middle. They start actions like humans, but they execute like software. Traditional identity has no framework for this. It cannot express why an agent exists or if its behavior aligns with its purpose. That void is where the real governance failures happen. The cost of staying in the old model. You're operating in this state right now. Agents are running across your environment. Some are known, many are not. The ones you do know about are running under service principles with broad permissions, because nobody could figure out exactly what they'd need. The ones you don't know about are doing whatever they were built to do, with whatever access the creator decided to give them. What does this actually cost? Start with the security side. That overprivileged service principal is a target. It isn't malicious intent that creates the problem. It's inevitability. An attacker compromises an endpoint where that credential is stored, or they trick an employee into running a script that steals it, or they find it checked into a GitHub repository. The moment that credential is in an attacker's hands, they have access to everything that service principal can touch. They have the blast radius of an administrator without any of the controls. Because a God account has no restrictions, it can read your customer data. It can write to your financial systems. It can delete your audit logs. And it does it all while the access looks legitimate. The cleanup doesn't take days, it takes months. You have to assume every system the principal touched was compromised. You have to rotate credentials for everything downstream. You have to audit 6 months of logs to see what was actually accessed. You have to notify customers if their data left your control. You have to brief your board on a security incident. The financial cost of a single breach of this nature runs into millions, but the daily cost is subtler and more pervasive. At scale, you have hundreds of agents, maybe thousands if you're a large organization. Each one needs permissions. Each one should follow least privilege in theory. But in practice, the process of determining exactly what permissions each agent needs is exhausting. So IT doesn't attempt it agent by agent. Instead, they push back on the request. They tell the team building the agent that it needs to go through a formal governance process. That process takes weeks. The team gets frustrated. They build the agent anyway. Shadow AI again, because the official path is too slow. Or they settle for permissions that are too broad just to move forward. Either way, you're not scaling agents, you're suffocating them in bureaucracy. The security team, meanwhile, is drowning in incident response. Someone reports unusual activity. The team has to reconstruct what happened without good visibility into which agents exist, which teams own them, or what they're supposed to be doing. They're not preventing incidents. They're responding to them after the fact. That's expensive staff time that should be spent on strategy instead of being consumed by firefighting. And compliance. Your compliance team is in an impossible position. An auditor asks, which agents have accessed customer data in the last 90 days? The answer should be a query. Instead, it's a month-long investigation. You have to manually contact teams, review logs, trace permissions backwards, and hope you didn't miss anyone. You can't prove controls were in place because the controls aren't really there. Not in any structured sense. The best you can do is show that some people with access had it, but you can't prove they didn't misuse it, and you can't prove that unauthorized access was prevented. The compliance failure doesn't result in an incident you can point to, it results in failed audits, regulatory fines, customer contracts lost because you can't certify your controls, insurance premiums that climb every quarter. Organizations that stay in the old model end up spending 40% more on identity governance than they should, not because the technology is expensive, but because the model is fundamentally broken. You're trying to govern a system that was never designed to be governed this way. It's like trying to use a spreadsheet as a database. You can technically do it, but you spend all your time fighting the tool instead of solving the problem. The real opportunity cost is where it hurts most. You're not scaling AI adoption because you don't have the governance foundation. Agents could automate significant work. They could unlock efficiency, but you can't approve them fast enough or govern them safely enough to deploy them at the scale where they matter. So the pilots stay pilots, the proof of concepts stay proof of concepts. The competitive advantage you could gain by automating your processes goes to organizations that figured out how to govern agents properly. This is where the model fundamentally breaks down. Why traditional identity models fail for agents? Let's be precise about what the traditional identity model actually does and why it collapses under agent workloads. Role-based access control was built on a simple premise. You assign a user or application to a role. That role carries a fixed set of permissions. The administration is straightforward. A human resources administrator gets the HR role, which includes read-write access to employee records. A database service account gets the database reader role, which includes read-only access to specific tables. The permissions don't change unless you explicitly change them. The role is static. The person or service holding that role is expected to use those permissions in predictable, consistent ways. This model works when behavior is predictable. It fails when it's not. An agent isn't assigned a role and then operates within it. An agent evaluates a problem. It decides what information it needs. It determines which systems can provide that information. It requests access, and it uses what it gets to make a decision. That decision informs the next action. That action might require access to a completely different system. The permission structure is dynamic. The intent behind each access is contextual. The role framework has no vocabulary for this. More fundamentally, the traditional model conflates several distinct pieces of information into a single credential. A service principal represents simultaneously the technology platform that's hosting the agent, the specific agent instance running on that platform, and the user or business context the agent is operating within. All three are baked into the same token. The system sees the token and makes a binary decision, yes or no. It never asks which of those three pieces is actually relevant to the question being asked. Consider a practical scenario. An agent running in your Azure subscription makes a request to access a SharePoint site. The system checks. Does the service principal have read access to SharePoint? Yes. Access granted, but the system never asked or answered several critical questions. Is this agent supposed to be accessing SharePoint at all? We know the platform can host agents. We know something that identifies as an agent is making the request. But is this the right agent? Is it acting in the right context? Is it accessing the right site? Should it be reading this particular type of data? Managed identities made this problem slightly better in Azure scenarios by eliminating secrets. But they didn't solve the core issue. They're still workload identities. They assume a one-to-one relationship between an identity and a resource or service. An Azure function has a managed identity. That identity authenticates the function to downstream services. But when you have multiple agents running inside that function, or when the same agent needs to operate in different contexts, the model breaks again. You still can't distinguish between distinct agents. You still can't express contextual policy. The structural mismatch is this. Traditional identity models were designed for systems where you could predict behavior in advance. You knew what role a person would have. You knew what a service account would do. You could write policy based on those predictions. Conditional access logic works on this assumption. If the user is new, if the device is non-compliant, if the location is unfamiliar, then escalate. The system detects deviation from expected patterns and responds, but agents don't have a predictable baseline. The first agent doesn't have a history to establish a baseline against. A new agent that behaves in ways the old agent never did isn't necessarily acting anomalously. It might be functioning exactly as intended. The policy framework has no way to distinguish intentional new behavior from compromised behavior. What you actually need from an identity system for agents goes far beyond yes or no access decisions. You need to know, what is this agent? Why was it created? Who is responsible for it? What type of data can it touch? What class of operation is it attempting? Read, write, execute? Is it acting on behalf of a specific user or autonomously? Has anything about its behavior changed since it was approved? Does the action it's attempting align with the data boundaries we define for this class of agent? Traditional identity models answer none of these questions. They were never designed to. And as long as you're forced to work within that framework, you're trying to govern agents with a system that has no comprehension of what agents actually are. The 3 identity types in the new model. For 20 years, enterprise identity was a binary world. You had users, humans with passwords and MFA who logged into apps to get work done, and you had workloads, the background services and code that talked to databases without any human involved. The entire system was built on this split. Users got conditional access, workloads got service principles, 2 categories, 2 patterns. This model worked because it matched reality. A human started a task, the software finished it. It was clean and easy to govern. Agents break this model. They aren't users. They don't have a human lifespan or a desk in an office. An agent doesn't have a start date from HR or an offboarding meeting when they quit. They don't sit in an org chart. They don't need MFA because they don't have a physical phone or human habits that hackers can exploit. But they aren't workloads either. A workload is static. It does the same thing every time it runs. A database account reads a table. An integration moves data from A to B. The scope is fixed. The behavior is predictable. An agent is different. It makes decisions. It looks at conditions and chains actions together based on what happens next. Its behavior depends on reasoning and input, not a pre-written script. So now, your ecosystem has 3 distinct categories: users, workloads, agents. Each one has a different threat model. Users get phished. Workloads get their keys leaked in code. Agents face both of those, plus a third: goal hijacking. Someone can use a prompt to trick the agent into doing something it wasn't designed for. The agent's own logic becomes the weak point. They also act differently. Users work 9 to 5. Workloads run on a schedule you set. Agents work on demand, scaling up and down whenever a request hits. They create a totally different type of audit trail, and they need different governance. HR manages users. Platform teams manage workloads through deployment pipelines. But agents are built by business teams on self-service platforms. They are deployed constantly. You have to validate them against business goals, not just technical specs. But here's the problem the old model couldn't solve. Who owns an agent? With a user, you look at their manager. With a workload, you look at the app team. But if a marketing team builds an agent in Copilot Studio that touches 3 different clouds, who is accountable? Who approves the permissions? Who investigates when it goes off the rails? This is why Entra Agent ID exists. It isn't just a feature, it's a structural requirement. Agents are now first-class identities in the directory. They get their own object ID. They get their own policies and lifecycles. The audit logs show exactly what the agent did and why. You can govern them like users, with access reviews and risk scores, while they authenticate like workloads. That is the shift. We are moving from a binary model to a ternary one. The blueprint hierarchy, blueprints, principles, identities, users. So you have this third identity type. But how do you actually organize it? How do you stop every agent from becoming a snowflake that needs its own custom setup? The answer is hierarchy. The model isn't flat. It's built in 4 layers. And if you want to scale from 5 agents to 500, you have to understand how they fit together. It starts at the top with the agent identity blueprint. Think of this as the master template. You don't make a blueprint for every agent. You make them for types of agents. You have a blueprint for productivity agents that handle calendars and tasks. So you have one for data agents that can read databases but never edit them. And you have one for transactional agents that can change records but only with human approval. The blueprint is where the policy lives. It decides which credentials can be used. It sets the permission baseline, what is allowed by default, and what needs a manager to sign off. It even sets the expiration date. Blueprints are opinionated. That's the point. A high-risk blueprint automatically blocks write operations. It forces the agent to use temporary permissions that vanish after the job is done. A low-risk blueprint allows the agent to read internal docs without any extra hurdles. The power here is consistency. You define the policy once at the top. Every agent built from that template gets it automatically. If you need to tighten security, you update the blueprint and the change flows down to every agent using it. No more forgetting to update that one old agent running in the corner. The second layer is the blueprint principle. This is the version of the blueprint that lives in your specific tenant. The blueprint itself might be a global standard, but the principle is what actually issues the tokens. It's the engine that handles the authentication. It also owns the audit logs for every agent in that group. The third layer is the agent identity. This is the specific agent. It has its own ID in the directory. It inherits the rules from the blueprint, but it also has its own metadata. It has an owner, a human sponsor, and a live risk score based on what it's actually doing. The fourth layer is the agent user. This is a fallback for old systems. Some legacy apps don't understand what an agent is. They only want to see a user token. So you can link a user object to the agent identity for backward compatibility. Why build it this way? First, scale. One blueprint can support hundreds of agents. When a team builds something new, they don't start from zero. They pick a blueprint and the security is already handled. Second, governance. The blueprint is where the auditors look. It's version controlled and documented. Every policy decision is tracked at the source. Third, speed. This reduces the load on the people actually building the agents. They don't need to be security experts. They just pick the template that fits their use case and get to work. Human oversight moves to the blueprint layer. That's where you get the most leverage. Conditional access for agents, not just users. Conditional access is a policy engine. It was built on a single insight about risk, that not all access requests are equal. A user signing in from their desk on a company laptop during the day is low risk. But if that same user tries to sign in from a new country at 3 a.m. on an unmanaged device, the risk is high. The policy trusts the first scenario and demands more proof for the second. This logic changed everything for user security. We moved away from a simple yes or no model and started using context. The system looks at the risk profile in real time and decides what to do. If it's too risky, it asks for MFA, and if it's dangerous, it blocks the request entirely. Now, that same logic applies to agents, but the signals are different. A person has behaviors and an environment. You can track where they are or what device they use. An agent doesn't have a physical device or a home office. Its risk profile isn't about where it is, it's about what it's trying to do. Conditional access for agents uses 3 new signals to make these decisions. First, agent risk. Identity protection now scores agents just like it scores people. It builds a baseline of what normal looks like for every agent. It tracks how often the agent asks for data, what kind of data it wants, and how many requests it usually makes. When the agent starts acting weird, like suddenly grabbing thousands of files or touching data it has never used before, the risk score goes up. A low-risk agent stays trusted, but a high-risk agent gets shut down. Second, action risk. This is where your policies get specific. The system doesn't just check if the agent has permission. It looks at the context of the action itself. Reading a file is one thing, but modifying it or deleting records is much riskier. Sending data to an external channel is a different level of threat than querying an internal database. You can write a policy that lets an agent read customer records on its own, but requires a human to click approve before it can write or change anything. Third, context risk. The same action might be safe at noon, but dangerous at midnight. If an agent is working from a network you control within a normal time window, the risk is low. But if that same request comes from an unvetted IP address or a runtime environment that lacks your security controls, the profile changes instantly. You can make this very tangible with concrete policies. You can tell the system to block every unverified agent by default so that only explicitly approved agents can even start. You can restrict high-risk agents so they only work on compliant networks. You can even set a rule that says any agent touching confidential data must have a human in the loop. The agent can't just read the file. It has to ask a person first. The most important part is that this enforcement happens at the identity layer. You don't have to patch the agent or change a single line of code. You don't have to revoke credentials and redeploy the whole thing. You just update the policy. The next time that agent tries to do something, the engine evaluates the request and stops it if it doesn't fit the rules. If an agent starts acting out, trying to scrape 10,000 files in 60 seconds or emailing an unknown address, the system catches it. The pattern is wrong. The action doesn't match the baseline. Conditional access blocks it immediately. The damage is contained, and you get an alert to start your investigation. This is policy enforcement at the speed of the modern threat environment. Agent Registry, the single pane of glass. This is where the model hits the reality of how you actually work. In most companies, agents are running in 5 different places at once. Some are native to Azure, built in Copilot Studio or AI Foundry. Those are easy to see and manage because they live in your Microsoft environment. But then, things get messy. Finance built their own agents on AWS Bedrock because they liked the specific tools there. Marketing went with Google Vertex for their own model choices. Your sales team is using agents inside Salesforce, and your developers have custom frameworks running on their own servers. Every one of these platforms has its own way of tracking things. AWS has CloudTrail. Google has its own logs. Salesforce keeps its own records. They are all capturing data, but none of them are talking to each other. You end up with islands of information. You have fragmented visibility, which means you can't answer the most basic question: how many agents do we actually have? This isn't just a theoretical problem for architects. It's a daily reality for any company with a hybrid cloud strategy. The agent in AWS can't see the one in Azure, and your security policies in Entra don't mean anything to a Bedrock agent. The result is a total failure of governance. You might manage each platform well on its own, but you can't see the big picture. You can't spot patterns across clouds, and you definitely can't enforce one consistent set of rules. This is why the Agent Registry exists. The registry is the Entra solution for this fragmentation. It doesn't replace the tools in AWS or Google. It sits on top of them as a central metadata store. It keeps track of every agent in your company, no matter where it lives. It records the name, the purpose, the owner, and the blueprint it's supposed to follow. It knows what data the agent touches and what its current risk score is. There is a new feature called Registry Sync that pulls all this together. You connect Entra to your AWS or Google environments, and the sync process finds the agents living there. It pulls their details into Entra, so you have one unified view of your entire ecosystem. And here's the shift. Once that AWS agent is in your Entra registry, it's no longer invisible. You can give it an Entra agent ID. You can apply your conditional access policies to it. You can put it through the same access reviews as your native Azure agents. The agent stays in AWS. It keeps using the same APIs and services it always did. But the governance, the rules, and the audit trail now flow through one central place. This solves the problem of islands without forcing everyone to use the same platform. Cross-platform agent governance, the Agentic Fabric. The Agent Registry solves visibility. You can see all your agents now, but seeing them is only the first step. The real question is, how do you govern them consistently when the infrastructure itself is fragmented? This is where the concept of the Agentic Fabric enters. It isn't a product, it's a mental model. It's the framework for how governance actually works when agents exist across multiple clouds and platforms simultaneously. The Agentic Fabric isn't about moving workloads. You aren't consolidating everything into one cloud. Finance keeps using Bedrock because it fits their use case. Marketing keeps using Vertex for their reasons. And your native M365 copilots stay exactly where they are. The fabric sits above the infrastructure. It imposes uniform governance without requiring you to move a single piece of data. It operates in 5 distinct layers. The first layer is discovery. The agent registry syncs with your cloud platforms and finds agents wherever they happen to be running. But discovery is continuous, not a one-time event. New agents are created constantly. Some are built through official channels, while others are shadow agents that emerged without formal approval. The discovery process runs around the clock, identifying agents that haven't been registered yet and flagging them for triage. The second layer is identity. Every agent that's discovered gets an Entra agent ID. That identity becomes the anchor point for everything else. The agent running on AWS now has an Entra identity. The Salesforce automation now has an Entra identity. And that identity isn't tied to where the agent runs. It's portable. It travels with the agent conceptually, creating a consistent governance identity across every platform you use. The third layer is policy. Conditional access and risk-based controls apply uniformly across the fabric. You write a policy that says agents accessing customer data must have human approval. That policy applies to the agent on AWS, the agent on Google, and the agent in Salesforce. You don't write AWS-specific policies and Google-specific policies. You write one policy that applies across the entire fabric. The enforcement happens through Entra, and the agent's home platform doesn't even need to understand the policy. It just needs to respect the token decisions that Entra makes. The fourth layer is observability. Logs flow from all your platforms into a central CM. AWS CloudTrail events, Azure activity logs, and Salesforce audit logs all flow to a single place. The logs are correlated and analyzed together. You can track an agent action that spans multiple platforms, seeing the complete sequence of what happened in chronological order. The audit trail is unified even though the platforms are separate. The fifth layer is lifecycle. Agents are created, reviewed, and decommissioned through a unified process. You don't have separate workflows for AWS agents and Azure agents. You have one process that applies to all agents, regardless of where they run. An agent created in Bedrock goes through the same approval workflow as an agent in Copilot Studio when an agent needs to be retired. A single decommissioning process removes it from the registry and communicates that retirement across all platforms. The benefit is profound. You can answer questions that are impossible to answer in a fragmented environment. Which agents have accessed customer data in the last 90 days? You query the unified registry and audit trail, and you get an answer if an agent is compromised. What's the blast radius? You look at its permissions across all platforms and see everywhere it could have caused damage. Is this agent still in use? You check its activity across all systems. Can we decommission it? You trace all its dependencies across the fabric. But getting there requires a fundamental shift in thinking. Governance is no longer the responsibility of individual platforms. AWS doesn't govern the Bedrock agent. Google doesn't govern the Vertex agent. Entra does. It's organizational governance imposed on infrastructure, not infrastructure governance delegated to platforms. This requires coordination. It requires buy-in from security, from cloud teams, and from compliance. It requires treating identity as the control plane that sits above the infrastructure, not as a property of individual systems. That coordination is what the next phase actually operationalizes. Least privilege orchestration, the blueprint in action. Understanding the theory of least privilege is one thing, implementing it in practice is another. The challenge with agents is that they aren't static workloads. You can't simply say, this agent needs read access to this database and be done. An agent might need to read from a database, but it might also need to create a task, send a notification, and update a record. Those operations might be necessary, but only in specific sequences. Granting everything upfront creates risk. Trying to gatekeep every edge case becomes administratively suffocating. The blueprint approach solves this by encoding permission logic at the template level. Here's how it actually works. Start with definition. You're designing a blueprint for an HR agent that handles new hire onboarding. Its purpose is narrow. Collect information, create a checklist, schedule orientation, and assign initial tasks. That's it. You aren't asking the agent to process payroll or modify benefits. That focus matters. Everything the agent needs follows from that single purpose. Now you translate purpose into permissions. The agent needs to read from your HR system, and it needs write access to a specific SharePoint site where onboarding documents live. It needs permission to create tasks in Teams. That's the legitimate scope. Not all of SharePoint, but this specific site. Not all Teams tasks, but this specific Teams channel. You document restrictions explicitly. The agent cannot read from other departments' data. It cannot modify payroll information. It cannot access email. These aren't just recommendations. They're enforced at the identity layer. The agent's token, issued by the blueprint principle, has these boundaries baked in. Even if someone wrote code in the agent that tried to access forbidden data, the token wouldn't authorize it. The platform would reject the request. Then you handle the gray areas. What if the agent encounters a situation outside its design? A new hire with special accommodations, or a complex background check issue? The agent shouldn't make autonomous decisions here. It should escalate. You build approval workflows into the agent's logic, but you also enforce them at the policy layer. If the agent tries to proceed without getting human approval, conditional access blocks it. The agent can't force its way through. The actual enforcement happens through a combination of mechanisms. The blueprint principle's token includes scoped credentials. They have limited scope and can only be used for specific graph API calls. The Azure role assignments for the agent are restrictive. The conditional access policy attached to this blueprint says, any write operation to payroll systems is blocked. Any external data export is blocked. Any action outside the approved Teams channel is blocked. These controls operate independently. If one fails, the others catch the violation. Here's the operational advantage. You can scale this safely. You design one blueprint for this category of HR agents. Every HR agent created from that blueprint inherits the same permission boundaries, the same restrictions, and the same approval workflows. When you onboard a new HR team, they don't need custom governance. They use the existing blueprint. The controls are already there when policy needs to change. You update the blueprint. Every agent using it inherits the change. No per-agent configuration. No drift. The blast radius is contained. If an HR agent is compromised, its access is already constrained. It can't exfiltrate payroll data because it doesn't have access to payroll systems. It can't modify customer records because it doesn't have permissions outside the HR domain. The damage it can do is proportional to the permissions it actually holds, not the permissions you granted it because you couldn't figure out exactly what it needed. This is how you scale agents safely. Observability and attribution, who did what and why. You have designed the policies, created the blueprints, and enforced the controls, but enforcement is only half the story. The other half is knowing what actually happened. Traditional logging gave you a bare fact, like telling you that service principal X accessed resource Y at 10 a.m., and that was the extent of the information. If something went wrong, you had to manually investigate by finding which application used that service principal and interviewing people about why it accessed that resource. You had to reconstruct context that the log itself never captured, which often meant the most important details stayed trapped in someone's head. The new logging model is qualitatively different because it provides a complete narrative of the event. Agent A, owned by Team B and acting on behalf of user C, accessed file D at 10 a.m. to perform a read operation. The result was success, the risk score was low, and everything you need to understand the situation is right there in the record. This data isn't scattered across multiple systems or hidden in a human's memory, but lives directly in the audit trail itself. The log captures 4 distinct elements working together to provide total visibility. Agent sign-in logs record the moment of authentication, showing when the agent signed in and which network it used. It verifies if the token was issued by the expected blueprint principal and checks if the risk score was within the expected range. These are the foundational questions that tell you whether the agent's very presence in the system was legitimate. Action logs record what the agent actually did, moving beyond a simple note that access occurred to show specific operations. It logs whether the agent read a file, created a task, updated a record, or queried a database. Each action is recorded individually with its parameters and results. So if an agent reads a file, the log captures which file it was and how much data was transferred. If it updated a record, the log captures the before and after states so you can see exactly what changed. Audit logs record who approved what and when, which is vital if the action required a human sign-off. If the agent hit an approval workflow, The log captures which human approved it when they did it and what context they saw when they made that decision. If the action was blocked by conditional access, the log captures that too, showing you exactly why it was blocked and which specific policy triggered that stop. Risk logs overlay behavioral analysis on top of these operational records to see if the access was anomalous. It asks if the behavior deviated from the agent's normal pattern or if the action was consistent with the intended purpose of its blueprint. The risk assessment isn't a separate process running in a black box, but is recorded in the audit trail so you can see how the system evaluated the situation in real time. Consider a real scenario where an agent starts exfiltrating files to an external email address. The moment it attempts this, the system recognizes it as anomalous because the agent has never contacted this email address before. The action of sending customer data to an external email is flagged by DLP as a high-risk operation, and conditional access evaluates the context and decides to block it. The agent cannot complete the exfiltration, and the audit trail captures the entire sequence from start to finish. You can see the agent's normal activity leading up to the attempt and the exact moment the anomaly was detected. You can see which policy triggered the block and at what point the action failed, allowing you to reconstruct exactly what the agent tried to do. For compliance teams, this is transformative because they no longer have to launch a massive investigation when a regulator asks which agents accessed customer data. Instead of guessing, you run a query against the audit trail and get a structured answer. Agent X accessed customer data on these dates. It was owned by Team Y, and here is the audit evidence showing what it did. You can prove that controls were in place and enforced with actual evidence rather than a best effort guess. For operations teams, these same logs enable continuous improvement by showing which agents are used regularly and which haven't been touched in months. You can make data-driven decisions about which agents are valuable and which are candidates for retirement. You see which ones trigger the most exceptions, which tells you something about their design, and you can spot behavioral drift before it becomes a real problem. Designing agent blueprints, from theory to practice. Now you understand what the control plane does, how conditional access enforces policy, and how the registry provides visibility. But where does the policy itself come from, and who decides what agents can and cannot do? You have to translate an abstract framework into something concrete that actually works, and this is where blueprints move from concept to practice. A blueprint isn't a feature, but a governance artifact that represents a structured decision about what a category of agents is allowed to do. It defines how their permissions are scoped and what controls apply to them, encoding organizational policy directly into the identity system. This replaces the old model of relying on manual processes or just hoping that teams will follow the guidelines. Think of building a blueprint as answering a series of specific questions about what the agent is supposed to do. You need to define this in concrete operational terms rather than marketing language. An IT support agent triages tickets, gathers diagnostic information, and suggests solutions, and that is its entire scope. Everything you authorize flows from that single definition, and everything outside that scope is restricted. The blueprint captures this in 5 distinct dimensions, starting with identity, which covers how the agent authenticates. It tracks whether the agent uses a managed identity, a federated credential, or a certificate, focusing on the token issuance mechanism. This ensures the agent's credential can be rotated automatically rather than requiring manual intervention. Permissions then define exactly what the agent can touch, such as whether it can read from one specific SharePoint site or the entire environment. Policies define the controls that wrap around those permissions, including conditional access logic, DLP rules, and approval workflows. These aren't decided for every individual agent, but are set at the blueprint level and inherited automatically. Lifecycle rules specify how the agent evolves over time, determining when it should be reviewed and if approval needs to be renewed quarterly. It also sets the maximum lifespan and determines what triggers the agent to be disabled automatically. Metadata captures the contextual information that makes governance possible by identifying who owns the blueprint and what risk tier it falls under. This metadata is searchable and queryable, which is how you answer questions about which agents can access customer data. Organizations typically design blueprints along risk tiers to provide a practical way to segment governance complexity. Low-risk blueprints govern agents that read internal knowledge bases like documentation, FAQs, and process guides. These agents don't touch sensitive data and can't modify anything, so they operate with minimal human oversight. Because the downside of them acting autonomously is just wrong information rather than system damage, you can approve these quickly and let them run. Medium-risk blueprints cover agents that can read and modify internal systems, such as an HR workflow agent or a procurement agent. These need human approval for certain operations, especially writes. And while they can read data autonomously, modifications require explicit authorization. You review these quarterly or whenever their permissions change to ensure they stay within their intended scope. High-risk blueprints protect agents that touch sensitive data or execute critical operations, like an agent accessing customer financial information. Every single operation requires human-in-the-loop approval, meaning the agent cannot act autonomously at all. It exists to assist, gather information, and recommend, but the human always makes the final decision. Here's a concrete example of an IT support agent in the medium-risk tier designed to triage support tickets. Its permissions include read access to ServiceNow tickets in the knowledge base, but it is restricted from closing tickets or accessing customer data. If the agent encounters a critical issue like a production outage, its approval workflow forces it to escalate to a senior technician. The lifecycle is reviewed quarterly, and any changes to its permissions require explicit security team approval. The operational reality is that blueprints aren't designed in isolation, so you must work with business teams to understand their needs. You work with security to define the constraints and compliance to ensure the policy is auditable, then you iterate. As agents built from this blueprint actually operate, you learn whether the design was right and adjust for edge cases. The governance benefit is multiplication because you design the policy once and hundreds of agents inherit it. When you need to tighten controls or respond to a security incident, you simply update the blueprint. Every agent using it inherits the change immediately, which eliminates per-agent reconfiguration and prevents policy drift. That is how you scale governance from 5 agents to 500 without drowning in administration. The approval and lifecycle workflow, how agents get born and die. Agents don't just appear out of nowhere. Someone has to build them. Someone has to decide if they're allowed to run. Someone has to watch them. And eventually, someone has to turn them off. That journey from the first idea to retirement isn't an accident. It's the operational model that makes your control plane actually work. Because without a structured lifecycle, you get chaos. Teams start building agents in the shadows. Nothing gets tracked. Stale agents pile up because nobody remembers they exist. Permissions never get reviewed. That's the current state in most organizations, but with a lifecycle. Approval becomes a gate. It stops dangerous agents from running while making the safe ones move faster. The process starts with a request. A team wants to build an agent to automate expense reports, or triage support tickets, or just summarize their daily emails. Whatever the use case is, they have to describe it. What does it do? What data does it touch? Who is it for? That request goes to an agent governance board. These aren't just random executives. They're people from security and architecture who understand your risk tolerance. Then comes the design review. The board looks at the request and asks the hard questions. Is this agent's purpose narrow enough? We approve agents that do 3 things. Agents that try to do everything usually fail, or they create massive risk. They look at the data domains. Customer data is too vague for a real policy. Read-only access to billing addresses for invoices is specific. That specificity is what determines which blueprint you use. If it's a standard task, an existing blueprint handles it. If it's novel, like an agent accessing data we haven't governed before, you need a new blueprint. The board assigns that blueprint and defines the scope. What can this agent actually do? Where does a human need to step in? For an expense agent, maybe it handles anything under $500 alone, but a manager has to see anything higher. For a support agent, it can answer questions, but it can't promise a refund once the design is locked. You deploy. The team builds the agent using that approved blueprint. The moment it's ready, they register it. The agent registry isn't optional. The agent does not go live until it's in the system with an owner, a purpose, and an intra-agent ID, because the policies are defined at the blueprint level. Conditional access is applied automatically. Now the agent is running. Logs flow to your CM. The governance team watches. Is it behaving? Is it touching files it shouldn't? If the agent starts making more requests than usual or breaks its historical pattern, alerts fire. If the risk score crosses a threshold, conditional access can block it instantly. Then you have the regular reviews. Every quarter or every year, you ask if this agent is still needed. If usage has dropped to 0 over 6 months, that's a signal to retire it. Retirement is the final phase. The agent is disabled, permissions are revoked, the data it accessed is reviewed for compliance, the agent is removed from the directory, and the whole thing is audited. Who approved the retirement? When? Why? That audit trail proves the agent didn't just disappear into a black hole. Here's the reality. This process isn't a bottleneck if you design it right. Approval should take days, not weeks. Monitoring should be automated. Retirement should happen by itself for unused agents. When the operations are right, the lifecycle accelerates innovation. It doesn't block it. Shadow AI discovery and risk triage, finding the agents you don't know about. Right now, your organization has agents running that you don't know about. It's not because you're incompetent, it's because building agents has become too easy, and governance hasn't caught up. A team in finance discovers Bedrock. They build an agent to analyze expenses. It works perfectly, so they just deploy it without telling IT. Marketing hears about it. They spin up an agent in Copilot Studio to draft social posts. Again, no formal process. A product manager built something in Azure AI Foundry to help prioritize features. 3 agents, 3 platforms, 0 registration. This isn't malice, it's just how organizations work. Teams move fast to solve problems, and governance is usually slow. That gap gets filled with shadow AI. The discovery process starts with an inventory. You scan the obvious spots first. Copilot Studio, Azure, AWS, Google, Salesforce. You look at API usage patterns. If an app is making thousands of Graph API queries to read email and move data, that's probably an agent. Then you just talk to people. You'd be surprised how many teams have automation running in Zapier or N8N that you never knew existed. You aren't trying to catch people doing something wrong. You're trying to understand the actual state of your environment, what exists, and who built it. That honesty is the starting point for governance. Once you have the list, you triage. For every agent you find, you ask 5 things. What is the purpose? Who owns it? What data does it see? Is it actually being used? Does it have any controls? Those answers put the agent into a 3-color system. Green is low risk, read-only access to internal knowledge, no way to change or delete data. You fast-track these. They get registered, assigned a blueprint, and brought into the fold quickly. The owner gets a note saying, "Your agent is now governed. Here are the policies that apply." Yellow is medium risk. It has write access or it touches sensitive data. These agents need more structure. You don't disable them, but you add requirements. Maybe it needs human approval for certain steps. Maybe it needs more frequent reviews. Red is an immediate concern. No owner, no controls. Accessing sensitive data with no restrictions. Red agents get disabled first and investigated second. You shut them down to prevent damage. Then you figure out if they served a real purpose that needs to be rebuilt the right way. But here's the critical insight. Discovery isn't a one-time event. New agents appear every day. Teams won't stop building just because you have a framework now. The process has to run continuously. Automated scans find the technical footprints, and manual interviews find what the scans missed. The goal is zero shadow AI. Not because you want to stop innovation, but because an ungoverned agent undermines everything else you've built. Every agent outside the system is a hole in your defense. Runtime enforcement and incident response. When agents go wrong, good policy prevents most problems. The right blueprint stops agents from touching data they shouldn't see. Conditional access blocks actions that look wrong. DLP stops data from leaking to the wrong places. But policy is defensive. It sets the boundaries. It doesn't stop a determined attacker or a new vulnerability. An agent's code gets manipulated, its prompt gets injected, or an attacker takes over the hosting environment. Something breaks the model's assumptions. When that happens, what stops the damage? 3 mechanisms work together in a sequence: enforcement, detection, and response. They aren't just set up at deployment and forgotten. They run constantly, checking risk and making decisions in real time. The enforcement layer stops bad actions at the token level. If an agent tries to open a confidential file without the right token, the request fails immediately. Conditional access sees the request is outside the agent's normal routine and blocks it. At the same time, DLP sees the agent trying to send customer records to a personal email and prevents the violation. Rate limiting notices the agent is hitting 50,000 API calls per minute and throttles the connection. These controls work on their own, so if one fails, the others are there to catch it. The detection layer finds the problems that enforcement missed. Logs from every system the agent touches flow into a central CM. An anomaly engine looks at these logs in real time to understand what normal looks like for this specific agent. It knows how often it runs, what it does, and how much data it usually handles. When the behavior changes, a signal fires. If an agent that usually reads 10 emails an hour suddenly reads 10,000, the system notices the anomaly. Risk scoring automatically bumps up the threat level. Analytics flag patterns that suggest a compromise, like an agent creating dozens of mailbox rules when it has never done that before. The system sees it. The response layer moves when detection flags a problem. An alert hits your security operations center, and the SOC team gets notified that an agent is acting out. They don't have to guess what is happening because they can see the specific actions and the policy evaluations. They see exactly what the agent tried to do and what stopped it. Investigation moves fast because the context is right there. If the agent is actually compromised, containment happens right away. Permissions are revoked. Conditional access blocks new requests, and the agent stops before any more damage occurs. Remediation comes next. You have to figure out if the agent itself was the problem or if the environment was breached. You check if it was a code flaw that needs a patch or if the prompt was manipulated. Different causes need different fixes. You rotate the credentials, redeploy the code, and look at what the agent accessed while it was active. You restore data if you have to, and document everything so the team learns from the incident. Learning is the final piece of the model. The team reviews the incident to see if the policy should have caught it earlier. They ask if the blueprint was too loose or if the detection rules missed something obvious. These aren't about blame, they're about design. You adjust the policy, update the blueprints, and sharpen the detection. The next time someone tries this, the response is faster and the damage is smaller. Look at a real scenario. A document agent starts sending contract text to an outside email address. The enforcement layers activate immediately. DLP sees customer contracts going to an unauthorized address and blocks the transfer. The agent can't finish the job. Detection notices the anomaly at the same time. This agent has never talked to this email address before, which is completely outside its normal pattern. The risk score spikes to critical and the agent gets flagged. The SOC team gets the alert and looks at the logs. They see the blocked attempt and check the agent's history, finding nothing wrong until that moment. They check the environment and find a prompt injection attack where someone used specific input to trick the agent. They rotate the credentials, fix the prompt safeguards, and check the data. The contracts never left the building because enforcement stopped it. The whole process from detection to containment takes minutes. It is prevention-focused instead of just reacting to a disaster. From governance silos to unified AI policy, breaking down walls. For 15 years, companies have organized themselves around a simple idea. Identity governance and security governance are different problems. They are owned by different teams with different budgets and different goals. The identity team handles users, groups, and access rights. They own the directory and the onboarding process. Their success is measured by how many access reviews they finish or how fast they get a new hire into the system. The security team focuses on threats and incident response. They run the CM and hunt for breaches. Their success is measured by how fast they detect and contain a threat. The compliance team handles the audits and the paperwork. They prove the controls exist. The data governance team classifies info and manages how long it stays in the system. They own the data dictionary. These teams rarely talk to each other unless something went wrong. An audit failure or a breach would force them into a room together, but usually they worked on parallel tracks. The identity team didn't think about data sensitivity. The security team didn't know which classifications applied to which systems. The compliance team wrote down rules without knowing if they were actually being enforced. This split worked for a long time because the world was smaller. People used apps, and apps used databases. The perimeter was stable, and policy moved slowly. You could afford to work in silos because the mistakes didn't hurt you as often. AI agents break this model completely. An agent doesn't fit into a single bucket. It is an identity that needs to be authorized. It is a security risk that can be exploited. It handles sensitive data that compliance cares about. It operates under rules that regulate classified info. You can't govern an agent by having 4 different teams do their own thing and hoping it works out. The unified approach changes that. Identity governance becomes part of AI governance. The question of what an agent can do is answered by one policy framework. Security rules like conditional access now apply to agents just as much as they apply to people. Compliance and audit trails are built into the identity layer from the start. Data classification is tied directly to agent permissions. If an agent isn't cleared for a certain type of data, it can't touch it. If data is set to be deleted, the agent's access ends automatically. The organizational shift is huge. You need a cross-functional team that most companies just don't have yet. You can't have identity, security, and data people working one after the other. You need them in the same room, designing policy together. When someone requests a new agent, the whole team reviews it at once. The identity architect checks the blueprint, the security engineer looks for exploits, the compliance officer checks the audit trail, the data steward looks at the classifications. This is a cultural change. The old way was, security says no. The new way is, security builds the guardrails. Compliance moves from a checkbox to code. Data governance moves from spreadsheets to active enforcement. This needs the C-suite to step in. Someone at the top has to say that AI governance is the priority and that the silos are over. Every team owns a piece of the result. It takes investment in tools, training, and a new structure. It takes time. But when you get it right, the payoff is worth it. The speed versus security trade-off. How to scale without losing control. The moment you bring up governance, you'll hear the same objection. People will call it IT bureaucracy. They'll say it slows them down. They'll tell you they need to move fast. The people saying this aren't wrong about the tension. Speed and control usually pull in different directions, but they're wrong about the result. Strong governance doesn't slow you down. It actually enables speed. And the moment your teams understand that, the resistance disappears. So what's actually happening is a shift in the math. Blueprints remove the friction at the point of creation. In the old model, a team wants to build an agent and they submit a formal request. Security reviews it, they ask questions, the team answers. Security asks more questions. Weeks pass while everyone is stuck in a back and forth, and the team stays blocked. Blueprints collapse that entire timeline. Now, the team just looks at your approved blueprint catalog and finds one that matches their use case. They build the agent using that pre-approved pattern. And it gets the green light in days because the policy decisions were already made. You aren't designing permissions from scratch for every single agent. You're just using patterns that already exist. Automation removes the manual steps that kill momentum. Traditional approval workflows are slow because they rely on humans. Someone gets an email. They read it, they decide, they reply. Every single one of those steps takes time. But when you enforce policies at the identity layer, you don't need human intervention unless something is actually wrong. If an agent tries to do something that violates a policy, the system blocks it instantly. There is no email, there is no waiting. It's just automatic. Clear guidelines stop the constant back and forth that destroys velocity. When teams don't know what's allowed, they feel like they have to ask permission for everything. They ask if this is okay or if they can try that, and every question becomes a conversation that causes a delay. Blueprints make the rules explicit. You can tell a team exactly what an agent with a specific blueprint is allowed to do. There is no ambiguity. Teams read the rules and move forward, and they ask fewer questions because the answers are already documented. But here's the problem people miss. Prevention is always faster than response. If a team discovers an agent is stealing data in the old model, they spend weeks investigating the mess. They have to figure out how it happened, how much data left, and what systems were touched. They have no audit trail, so they're stuck reconstructing events from broken logs while the business is disrupted. In the governed model, that data theft never happens. The policy blocks it in real time. The investigation is simple because the system caught it. The evidence is right there and the business keeps running. The real bottleneck isn't governance, it's clarity. Teams move slowly when they don't know what's allowed. They get cautious, they ask for permission, they wait. But teams move fast when they know the rules and understand the guardrails. They know exactly what they can do on their own and where they need a sign-off. They build within those lines, and they don't have to wait. This is the model you're actually building. The fast path is for agents that fit existing blueprints. These don't need a security review because the security decisions are already baked into the blueprint itself. They don't need custom approvals because the standard workflows already apply. You can get these approved in days. In a healthy system, this should be the majority. Maybe 70 or 80% of your agents will fit these existing patterns. The medium path is for agents that need a few tweaks to an existing blueprint. Maybe you have a blueprint for internal data access, but a new use case needs to touch a different data domain. You design a narrow variation. The security review is focused and quick, usually taking 1 to 2 weeks. Most teams find that timeline perfectly reasonable. The slow path is only for the truly weird stuff. These are the novel agents with unique requirements or high risks. They need custom designs and long reviews. You might spend weeks in discussions, but these should be rare. We're talking 5 or 10% of your agents at most. And if you want to know if this is working, look at the metrics. How long does it take to get from a request to a deployment on the fast path? If it's under a week, you're enabling speed. What percentage of your agents are actually using that fast path? If it's over 70%, your blueprint catalog is doing its job. You should also track your incident rate, because fewer incidents mean the governance is actually holding. If agent adoption is accelerating, then governance isn't a bottleneck. The goal is simple. Governance should be invisible to teams that follow the rules. It only shows up when someone tries to break a policy. And when it does appear, the blocker should be clear, not some mysterious piece of bureaucracy. You tell them they can't access that data because the blueprint doesn't allow it. And then you show them how to request a variation. Teams understand that. They either accept the limit or they start the right process to change it. Roles and responsibilities. Who owns what? Moving from siloed governance to a unified policy means you need total clarity on who does what. This isn't about boxes on an org chart. It's about functional responsibilities and how they overlap. In the old model, IT owned identity, security handled threats, and compliance gathered audit evidence. Everyone stayed in their own lane. But the new model can't work like that because agents touch everything at once. Let's look at the roles that actually matter. The agent sponsor is usually a business owner, like a director or a department head. They are accountable for whether the agent makes sense and whether it behaves itself. They didn't build the code, but they are responsible for why it exists. They approve what the agent can touch and what actions it's allowed to take. They have to review the agent regularly to see if it's still needed or if it's still following the blueprint. When something goes wrong and the agent causes damage, the sponsor is the one who answers for it. They own the decision to build it in the first place. The agent owner is the technical person who actually builds and maintains the code. They make sure the agent stays inside its blueprint during development. If there's an incident and the agent gets compromised, they're the ones who investigate and fix it. They also handle the updates when organizational policies change or when the business needs shift. The identity architect is the one who designs the blueprints and defines the policies. They review agent requests to make sure they actually line up with the rules. When a team wants to build something that doesn't fit the current blueprints, the architect either finds a variation or designs a new one. They also maintain the Agent Registry, which is the official list of what exists and what it's allowed to do. The security team is there to monitor agent activity. They watch the logs coming in from every platform and look for anything weird. When an agent starts acting suspicious, they investigate. When an attack happens, they contain it. They're also the ones recommending policy updates based on what they see in the real world. The compliance officer makes sure the policies actually meet regulatory requirements. They review the audit trails to prove the controls are working. They are the ones who certify to auditors that your governance is real and not just a theory. If an agent touches customer data, the compliance officer has to prove that access was authorized and logged. The data steward is the one who classifies the information. They decide what's public, what's internal, and what's confidential. They define which agents can access which categories of data. They also enforce the rules for how long data is kept. When an agent touches sensitive info, the steward reviews it to make sure it was appropriate. But here's the shift. These roles have to work together. When someone requests an agent, every stakeholder reviews it. The sponsor makes sure it solves a business problem. The architect checks the blueprint, security looks at the risk, the data steward checks the data access, and compliance makes sure it can be audited. When an incident happens, they investigate as a team. When policies change, everyone gets the memo. When an agent is retired, they coordinate the shutdown together. In the real world, this scales with the size of your company. If you're in a 50-person startup, one person might be the architect, the security engineer, and the compliance officer all at once. They wear a lot of hats. In a massive enterprise, these are dedicated teams with clear borders. But the key is clarity. Everyone needs to know what they are responsible for. And when a decision affects multiple teams, the handoff has to be explicit. That kind of clarity doesn't just happen. It requires someone at the top, like a CISO or an enterprise architect, to set the framework and keep it consistent. It requires meetings where all these people actually sit down and align. You have to accept that agent governance is a team sport, and it's not something any single department can do alone. The ROI, why this matters to the business. Building a governance framework for AI agents requires real investment. You need tooling, you need trained people, you need time to design blueprints and establish processes, and you need organizational change, which doesn't happen overnight. The question isn't whether it costs something, the question is whether the payoff justifies the cost. The answer is yes, but the payoff isn't just about preventing bad things, it's about enabling good ones. Start with risk reduction, because this is where the numbers are largest. Every prevented breach saves money. A typical enterprise data breach costs between $4 and $5 million. That's not just the incident response and remediation. That's lost business, regulatory fines, reputation damage, and the long tail of customer churn. An AI agent breach could be worse. An agent with broad access can cause damage at scale and speed that a human attacker couldn't match. The governance framework prevents most agent-driven breaches before they happen. DLP stops exfiltration. Conditional access blocks anomalous behavior. Audit trails enable fast detection. For a large organization, preventing even one serious breach pays for years of governance investment. The conservative estimate, one prevented breach saves $1 million. Most mature implementations prevent multiple breaches annually. Incident response becomes faster when you have complete visibility. In the old model, a security incident involving an agent took weeks to investigate. Which agent caused the problem? What did it actually access? Which systems did it touch? You're reconstructing events from fragmented logs. In the governed model, the answer is immediate. The audit trail shows exactly what happened, who authorized it, and what was blocked. Investigation shifts from reconstruction to confirmation. Response time drops from weeks to days. Every day saved is business impact reduced. Compliance becomes provable instead of aspirational. Regulators want audit evidence. Can you show which agents accessed which data? Can you prove controls were enforced? In the old model, the answer is usually, we think so, but we'd have to dig through logs. In the governed model, the answer is, here's the structured evidence showing exactly what happened, and that policy was enforced. Audit costs drop because auditors don't have to dig. You provide the evidence. For regulated industries, the difference between we can probably prove compliance and we have definitive proof can be the difference between a clean audit and major findings. Estimate 30 to 50% reduction in audit costs and investigation burden. Operational efficiency gains emerge because work that was manual becomes automated. Permission review, automated through access packages and risk-based scoring. Policy enforcement, automated through conditional access and DLP. Agent lifecycle tracking, automated through registry tools. Security teams stop firefighting and start strategizing. Identity teams stop handling exception requests and start designing better blueprints. Compliance teams focus on policy rather than manual evidence collection. The labor cost savings alone, fewer people required to do the same governance, typically runs 20 to 30% reduction in identity and security operations headcount. Innovation enablement is where the real value multiplies. When governance is clear and fast, teams build more agents. They build faster because they don't have to navigate ambiguous approval processes. They build more because they see the patterns that work. The innovation doesn't come from removing guardrails, it comes from making the guardrails transparent. Teams know exactly what's allowed. They know the fast path and the slow path. They build accordingly. Organizations that implement this model typically see 2 to 3 times more agent adoption because the bottleneck disappears. Data protection becomes active instead of reactive. Sensitive data classifications are enforced at the agent level through permissions. Retention policies automatically terminate agent access when data ages. Deletion happens without human intervention. The attacks that succeed in ungoverned data environments, lateral movement to sensitive systems, data aggregation, exfiltration, don't succeed here because policy prevents them at the identity layer. The total ROI for a large organization is substantial. Risk reduction from prevented breaches, $1 to $2 million. Compliance cost savings, $200,000 to $500,000. Operational efficiency, $300,000 to $500,000. Innovation enablement, $500,000 to $1 million in new business value from agents that wouldn't have been built otherwise. Total tangible benefit, $2 to $2.5 million annually. The investment, $500,000 to $1 million in year 1 for tooling, implementation, and training. Year 2 and beyond, $150,000 to $250,000 in maintenance and continuous improvement. Payback period, 6 to 12 months. After that, pure benefit. But the financial case is half the story. The implementation roadmap, how to get from here to there. Knowing what to build is one thing. Actually building it is something else entirely. The transformation from siloed identity governance to unified AI governance isn't a feature deployment that happens in a sprint. It's an organizational shift that unfolds across quarters. The roadmap that follows isn't theoretical. It's based on how organizations that have executed this successfully actually staged their work. Start with foundation, spanning months 1 through 3. During this phase, you're establishing the structural prerequisites. Assemble your cross-functional team, the people we discussed earlier, identity architects, security engineers, compliance officers, data stewards, and business stakeholders. They need to meet weekly. They need shared goals. Their first task is honest assessment. How many agents exist in your environment right now? How are they currently governed? Where are the gaps? This assessment surfaces shadow agents, unmanaged service principles, and policy inconsistencies. You're not trying to fix everything in this phase. You're trying to see clearly. As visibility improves, define organizational policy. What should agents be allowed to do? What's off limits? Which data domains are sensitive? What approval processes make sense? This isn't documented in a SharePoint site that nobody reads. It's translated directly into blueprints. Design your initial 3 to 5 blueprints covering the risk tiers. Low risk read-only agents, medium risk operational agents, and high risk data access agents. Simultaneously stand up the technical foundation. Enable Entra Agent ID. Configure conditional access for agents. Set up your agent registry. Get logging flowing to your CM. This foundation work sounds administrative, but it's critical. You can't operate a governance model without the infrastructure that enforces and observes it. The pilot phase runs months 4 through 6. You're now testing your designs in a controlled environment. Identify 5 to 10 agents already running in your environment, a mix of official and shadow agents. Migrate them into your new model. Register them in the agent registry. Assign them to blueprints. Apply conditional access policies. Monitor what happens. Do your blueprints actually work? Are the permission scopes right, or do you need to adjust? Test your approval workflows. Are they blocking legitimate work, or are they too permissive? Can you actually detect anomalies with your monitoring rules? Gather feedback from the teams using these agents. What's painful? What's working? What did you miss? This phase builds confidence. You're not betting the organization on an untested model. You're proving it works in a limited context. The pilot agents become your proof points when you expand. The rollout phase covers months 7 through 12. You're now migrating all agents into the new model. This isn't rapid because you need to maintain stability. You onboard existing agents in waves. You simultaneously run shadow AI discovery at scale. Comprehensive scans across all your platforms, looking for agents you don't know about yet. As you find them, you triage them. Green agents get onboarded quickly. Yellow agents get escalated for control additions. Red agents get disabled and investigated. You establish formal processes. How teams request new agents, how approvals work, how monitoring operates. You train people, a lot of people. Developers need to understand how blueprints work. Security teams need to know how to monitor agents. Compliance needs to understand the audit trail. Business stakeholders need to see how to sponsor agents responsibly. The optimization phase begins around month 13 and continues indefinitely. You're now operating the governance model at scale, but you're not done evolving. Monitor the metrics that matter. Are agents being approved and deployed faster than before or slower? What percentage follow the fast path versus needing custom review? Has your incident rate dropped? Is agent adoption accelerating? Use these signals to refine your blueprints. If you keep modifying the same blueprint, maybe it's not quite right. Expand to multi-cloud. If agents are running in AWS or Google, sync them into your agent registry. Apply Entra policies across platforms. Make governance organizational, not cloud-specific. The investment required isn't trivial, but it's predictable. Tooling and licenses, 100 to 200,000 in year 1. Personnel, 1 full-time identity architect, half-time security engineer, half-time compliance officer, training and change management, 50 to 100,000. Year 2 and beyond drops to maintenance costs, 150 to 250,000 annually. Success criteria are clear. 100% of agents known and governed, 80% of new agents following the fast approval path, incident response time under 1 hour, and accelerating agent adoption as the bottleneck dissolves. The future state, where this is heading. What is happening in your company right now is happening everywhere. It isn't happening because Microsoft or AWS are pushing it. It's happening because the market is demanding it. Autonomous agents are multiplying faster than your governance can keep up. And here is the shift. Within 18 months, the companies that build identity frameworks for their agents will move 3 times faster than everyone else. If you are still treating agents like service accounts, you are falling behind. This isn't a guess. It's a pattern we are already seeing in every enterprise that has committed to the model. The trends are obvious if you look. Agents are becoming ubiquitous. They are embedded in every process, every workflow, every decision. They are becoming more autonomous as the models get better, and the need for a human in the loop disappears. They are becoming interconnected, agent calling agent, orchestrating complex workflows that jump across systems and companies. They are becoming more powerful. Access is expanding, capabilities are deepening, the stakes are rising. But as that power grows, governance stops being optional, it becomes existential. You cannot scale autonomous agents without strong identity and policy controls. Companies that try to skip this, that deploy agents with zero governance, will find out the hard way. A compromised agent steals sensitive data at scale. A workforce agent makes a decision that violates compliance. One agent makes an error and it ripples through every dependent system you own. These incidents will happen. The only question is whether your governance framework catches them before they break your business. The technical direction is already converging. Agent ID is becoming the standard. This isn't just a Microsoft thing. It's an architectural pattern the whole industry is adopting. AWS is building agent blueprints. Google is implementing the same patterns. The industry is finally admitting that AI agents need first-class identity, not service principles pretending to be something else. Blueprints are becoming the standard way to write policy. Multi-cloud governance is now a requirement because nobody stays on a single cloud anymore. AI-aware policy engines are moving from a nice-to-have to a baseline security requirement. This shift isn't happening because vendors want to sell it. It's happening because customers are demanding it. The organizational direction is just as clear. Agent governance is now a C-level responsibility. Boards are asking how you govern AI the same way they ask about cybersecurity. Regulations are coming, and the AI Act in Europe is just the beginning. Other countries will follow, and compliance will become non-negotiable. Companies are building centers of excellence for AI governance because ad hoc approaches don't scale. These teams are expensive to build, but the cost of ignoring them is much higher. The competitive advantage belongs to the people who master this early. They scale AI faster because governance lets them move. It doesn't block them. They innovate faster because clear policies make approvals happen in days instead of months. They take bigger risks because their controls are transparent. They win customers because people trust companies that actually have control over their autonomous systems. This isn't about checking a box for compliance. It's about unlocking the potential of AI at scale. You cannot deploy thousands of agents without a foundation that makes that scale safe. The organizations that built that foundation today will be in a different league tomorrow. You started by treating agents like service accounts. It was a bridge from the old model. And it worked for a while, but that bridge is collapsing under the weight of what agents have become. Entra Agent ID isn't just a feature, it's a structural necessity. Blueprints aren't bureaucracy, they are how you scale. The Agentic Fabric isn't a Microsoft product, it's the operating model for the future of work. The question isn't whether you should build this, it's how fast you can get it done. Start now. Assess your current state, design your blueprints, build your processes. The organizations that do this will lead. The others will spend the next decade trying to catch up.